what would you guys like to do with this one? Any thoughts on this one? All right, you guys want to do, okay, so I got one with the x equals, that'll be 2 tangent theta, right? And one with just a u sub. All right, well, how many of you want to do the u sub and how many of you want to do the inverse trig sub? See which one works out better. U sub, Darius says u sub, u sub. All right, okay, let's do now the more people for now we're tied at 3-3 again. I could have made a poll, but I didn't. All right, well, let's just see what happens if we do it both ways. So let's start off doing it with the inverse trig method, because that's what we've been doing for the last few problems. So that'd be a substitution where x is equal to 2 tangent theta, right? And that would make dx equal to 2 secant squared theta d theta. Everybody agree with that? Yeah, okay. So what does that give us then? It gives us x cubed, which would be 8 tangent cubed theta times dx, which is another 2 secant squared theta d theta up in the numerator. And then in our denominator, we're going to have a cube root and then we're going to have a 4 tangent squared theta plus 4. And so as we take a look at this, if we pull this 4 out of here, we end up with tangent squared theta plus 1 inside of here, right? Which is a secant squared theta. And so we're going to end up with the cube root of secant squared theta, or secant to the 2/3 power. And having a secant to the 2/3 power down here in the denominator, it's going to be, looks like a little bit of an issue. Do you guys agree with that? Anybody see a good way to deal with a secant to the 2/3 power in the denominator? Yeah, not really a good way to deal with that, right? So this this cube root here is going to be an issue, right? When we had square roots, that worked out pretty nicely, generally so, because we ended up being able to square root this thing that was squared inside of here, but the cube root's going to be a problem with that. So looks like we're going to have to switch over and try a u sub. So what's the u substitution that you guys want to do then? Let u equal what? X squared plus 4. Okay, so then what's du equal? It should be 2x dx. And what else does that tell us here? Well, let's just start rewriting it. We've got x cubed. Well, what's x cubed? That'd be x squared times x, and we need to have it be a 2x, right? So if we put a 2 inside, we'll put a 1/2 outside. So x squared times 2x dx over our cube root of u. And now we should be able to turn the x squared into a x squared into what? To a u minus 4. So we ought to have 1/2 of the integral of u minus 4 over u to the 1/3 du. Everybody good with that or no? Molly, you want us to wait? Yeah, so the cube root causes an issue, Molly. I thought I answered Aiden's question, but the cube root causes that issue where normally with the square root, we're able to simplify that secant squared or tangent squared or sine squared or whatever we end up with in there to just a regular sine or a secant or a tangent. But with the cube root, it doesn't end up doing that, unfortunately. Yeah. All right, so how am I going to deal with 1/2 of u minus 4 over u to the 1/3 du? How do we integrate that? Can't I just make this u divided by u to the 1/3 or u to the 2/3? And then minus 4u to the negative 1/3? I just divide them both. Good or no? Everybody good with that? Okay, hopefully so. And then what do we end up with? We end up with 3/5 u to the 5/3. What does that come? Minus 6 u to the 2/3 plus our constant. And we'll just replace the u's with x squared plus 4's, and we can distribute that 1/2 through if we want. 3/10 of x squared plus 4 to the 5/3 minus 3 times x squared plus 4 to the 2/3 plus our constant. Everybody good there or no? All right, I'm going to assume everyone's okay. Let's take a look at this one. Any thoughts on this one? Okay, what's the u substitution that you want to do? You want u to equal x, Darius? That's just going to give us 1 over cube root of u, or 1 over square root of u plus cube root of u du. That's not going to change anything. So when we have two different fractional roots, so x to the 1/2 plus x to the 1/3 down here, we'll write it as that. Let's write this as 1 over x to the 1/2 plus x to the 1/3 dx. What we want to do is we want to figure out the common denominator between those and make that fraction, that has the least common denominator of those. So x to the 1/6 out of u. So anytime you see something like this was like x to the 1/3 plus x to the 1/4, you'd want to use u equals x to the 1/12. So let's see what happens here. If u equals x to the 1/6, how could I rewrite x to the 1/2? Okay, looks like some of you said u cubed, right? Yeah, good. So yes, if u is x to the 1/6, then x to the 1/2 is u cubed. And what's x to the 1/3 ought to be u squared, right? But what about this dx? I need to figure out what dx is. Well, couldn't I say that x is equal to u to the 6th if I just raise both those to the 6th power? Then I could take the derivative. Dx should be 6u to the 5th du. So I can replace my dx with 6u to the 5th du. Everybody good with that or no? So then we can simplify out what from all this? We can divide out a u squared from everything. Should give us 6u cubed over u plus 1 du. Everybody good with that? Yeah. 6 can come out if we want to. And we just end up with u cubed over u plus 1. If we pull the 6 out here, might as well do that. And then how are we going to deal with this integral? So here's a rule for us that we might want to think about and learn. Anytime you have a rational function, if there's just not a simple u substitution to use to simplify it and solve it, take the numerator and divide it by the denominator if the degree of the numerator is greater than or equal to the degree of the denominator. So since the degree of u cubed is greater than or equal to the degree of u plus 1, we're just going to divide u cubed by u plus 1. And what's the easiest way probably to do that division? Just do it synthetically, hopefully. -1, since we're dividing by u plus 1. 1u cubed, 0u squared, 0u, and 0. So using synthetic division, do the 1, -1, -1, 1, 1, -1, -1. And what do we end up with if we divide that? We end up with 6 times the integral of u squared minus u plus 1 minus 1 over u plus 1. Everybody good with that or no? So anytime you have a rational function, if the degree of the numerator is equal to or greater than the degree of the denominator, just divide them to start with. Everyone good there? Okay. No, let's put a new page here. So we need to integrate that. So that should be 6. And then what does that become? I think it was a u squared, right? So u cubed over 3. And I think we should have a minus u squared over 2, and then a plus u. And then what about this minus 1 over u plus 1? What does that become? That ought to become minus natural log absolute value u plus 1 plus a constant. Good or no? And then let's distribute the 6 through everything and then replace all the u's with x to the 1/6. So 6 over 3 is going to be 2. X to the 1/6 to the 3rd ought to be x to the 1/2 or root x. And then 6 divided by 2 ought to be 3. X to the 1/6 squared ought to be x to the 1/3 or the cube root of x. And then plus x to the 1/6, so plus the 6th root of x. So 6 6 roots of x. And then minus 6 natural log absolute value of the 6th root of x plus 1 plus your constant. Good or no? And I could have not had the absolute value around that natural log anymore because the sixth root is always going to be positive. And if you add 1 to it, it'll still be positive. But sure, I can go back a page. Everybody good with that? Any questions on that? All right, let's do another one. What do you think we should do here? What type of function do we have? We have a rational function. And this rational function, the degree of the numerator is greater than the degree of the denominator. So unless you see a real simple U substitution to use, what should we do first? We should divide them. How do we divide x cubed plus x by x minus 1? The easiest way is using synthetic division. So 1, it's x minus 1. 1x cubed, 0x squared, 1x, and 0. And just do your synthetic division. That's a 1, that's a 1, that's a 1, 1, 2, 2, and 2. Everybody good with that? So this becomes the integral of x squared plus x plus 2 plus 2 over x minus 1 dx. Everybody good with that? And so our integral should be x cubed over 3 plus x squared over 2 plus 2x plus 2 natural log absolute value x minus 1 plus a constant. Everybody good there? No. 2x. I have a 2x. This one right here? No, that's just a 2. Okay. This started with x cubed, so the first one down here becomes x squared. So if we start with the cubed and we're dividing using synthetic division, you start with 1 degree less, x squared plus x plus 2 divided by your original denominator. Does that make sense, Nick? All right. So what we're going to start to deal with, not today, we're gonna not do this today, we're going to do this tomorrow, probably tomorrow and Thursday, is we're going to learn how to deal with rational functions, because those are pretty easy, right? If the degree of the numerator is more than the degree of the denominator, they come out and work out pretty easily. Well, when that's not the case, if the degree of the numerator is less than the degree of the denominator, we got to do some extra stuff. And so that's what we're going to work on and deal with tomorrow. We're going to have a little bit of a short day today on lecture, and we're going to work on those next time.